All right, 2.1.4, multiplying and dividing rational expressions. The directions here state simplify the following rational expressions. When we look at the first problem, we have 5x squared over 10x to the fifth. We're just looking to reduce this fraction by canceling out factors that appear in both the numerator and the denominator. If we look at 5x squared, right, and we're dividing it by 10 times x to the fifth, we can take that 10 breaks into 2 times 5, and then an x to the fifth, we could even look at it as x squared times x to the third. So when we look at this here, we can find a couple of common factors that appear in both the numerator and the denominator, right? We've got our 5 divided by 5 is really the same thing as 1, and we've got x squared divided by x squared is really the same thing as 1. So in rewriting this, we'd have 1 over 2x to the third power. The second one, we've got a trinomial, x squared plus 7x minus 8 over x squared minus 1. Well, just like I broke that first problem up into factors, we'll do the same thing with this one. Let's factor the numerator. The numerator should be x plus 8 times x minus 1. And we're going to divide that by x squared minus 1, which is a difference of squares as well. So for that, we would have an x plus 1 times an x minus 1. So we can see here that the common factor that we have there, x minus 1 divided by x minus 1, is really like 1 over 1. And after we do that, we're just going to be left with x plus 8 over x plus 1. The third one's really important to look at here. We have x minus y over y minus x. And we're looking for a way to describe these. These are opposites. And we can tell they're opposites here if we gave them values. Let's say that like x was equal to 5 and let's let y equal 2. If we substitute in our 5 for our x, we'd be saying 5 minus, and then our 2 for our y, be like 5 minus 2 over 2 minus 5. When we do the math there, we'll end up with 3 over negative 3, which then when you look at it as 3 divided by its opposite, or 3 divided by negative 3, we're going to get negative 1. So anytime that we have opposites, right, we have x minus y, and the opposite of x minus y would be y minus x, okay, it's always going to end up equaling negative 1. So this has a value of negative 1. Another way you could kind of look at it here is if we were to take it and say, all right, we have x minus y, and if we were to divide it by that y minus x, let's factor the bottom. If we factor out negative 1, okay, we would have a negative 1 times, this would then become a negative y plus x. And if we rewrite that there, that's the same thing as saying x minus y over negative 1 times x minus y, just switching the order there. Well, now we've got that common factor between the two that's going to end up canceling out, leaving us with 1 over negative 1, which is just negative 1. So you can take it and factor out the negative if you need to, or if you just see it as if I have something over its opposite, it would also then equal negative 1. All right, so we're going to just look at a few of the basic ones to start out here, just with numbers. When we're looking at 2/5 times 3/4, remember when we're dealing with fractions, again, when we multiply straight across, it becomes one fraction. So it's like 2 times 3 over 5 times 4. This allows us then to look at the common factors that we would have. Now, some people like to do it this way instead. They'll say instead of rewriting 4 as 2 times 2, they understand that 2 goes into 2 one time and 2 goes into 4 twice, and they'll rewrite it like that and then take it and multiply it. So they'll say here that 1 times 3 is 3, and 5 times 2 is 10. So 3/10 would be our answer there. Something important to note here for the next one is we have 2/5 divided by 3/4. So the little golden rule there is we always want to take it here and multiply by the reciprocal of the second fraction. So instead of doing 2/5 divided by 3/4, that's equal to the same thing as 2/5 times 4/3. And when we take it and rewrite it as one fraction, we have 2 times 4 over 5 times 3. We don't see any common factors between the numerator and denominator, so we'll just go ahead and multiply them together to get our 8/15. Now I know these probably seem pretty basic, pretty easy, but if you can do this with these normal fractions, then we're going to follow the same procedure in working with our algebraic fractions. All right, the third example here, we've got a -2/3 divided by 7/9, but it's in fraction form. And if you're not comfortable with that, go ahead and rewrite it as -2/3 divided by 7/9. So we're dividing by the denominator. In which case here, that is going to be equivalent to -2/7 times the reciprocal of that second fraction, 9/7. I'm sorry, that wasn't -2/7, it was -2/3. Let me just fix that real quick. So we have -2/3 times 9/7. And if we would like to, we could take it and reduce it down. We know 3 goes into 3 once, goes into 9 3 times. So we're left with right now -2 times 3 over 1 times 7, which is going to be -6/7. So the key here, though, if you don't like, seeing fractions and fractions, take it, you can rewrite it as division, and then use your rules for dividing fractions to turn it into multiplication. So our math notes box here just says, when multiplying and simplifying rational expressions, it is necessary to first factor both the numerator and denominators before canceling out terms. So the first example we have, x² minus 4 over x² plus 4x plus 4 times x² minus x minus 6 over x² minus 9. All right, with this one, we can start out here with this x² minus 4. That is a difference of squares, which should end up being x plus 2 times the quantity of x minus 2. And that will be over this perfect square trinomial. We'll have x plus 2 times the quantity of x plus 2 times. Our numerator here should factor into x minus 3 times x plus 2. And that one is also over a difference of squares, so this one should be x plus 3 times x minus 3. Now that step of having to rewrite it as one fraction to be able to cancel isn't always necessary. Because I know this is going to be multiplication, this will end up being like one big fraction here. So I can go ahead and look for the factors that repeat in the numerator and denominator. So I have an x minus 3 here and an x minus 3 here. Those both end up being like 1. I have an x plus 2 here and an x plus 2 here, which would end up being 1 for each of those. And looks like I have another x plus 2 on this one that would cancel out with this x plus 2 up here. In the end, when we go ahead and multiply it straight across, it's like 1 times the quantity of x minus 2 times 1 times 1. So that ends up being just x minus 2 over, on the bottom we should get x plus 3. Now remember, we can't cancel out these x's here because they have other parts to them here. They have the x plus 3 and the x minus 2. Without the 3 and the 2, those factors change. So this is like one factor, this is like a factor. So we can only cancel it out with the exact same factor. So those x's will not cancel. So the next one here, we're going to have simplify the following rational expression. we have a to the third minus 6a squared divided by a squared plus 2a minus 3 divided by a to the third over a squared minus 2a plus 1. So first thing we're going to do here, let's go ahead and factor everything. On the top, we're going to factor out an a squared times the quantity of a minus 6. On the bottom, that should be an a plus 3 times the quantity of a minus 1. And we're going to actually, we'll just leave it as division for the moment, and then we'll talk about what happens when we change it to multiplication. So that's going to be an a to the third, and on the bottom, it looks like we have a perfect square trinomial, so a minus 1 times a minus 1. Now, if you're comfortable flipping and factoring at the same time, go ahead and do that. I have no problem with that there. I just sometimes see people will factor and forget to flip. So I'm going to go ahead now and just flip the second part. I have a squared times the quantity of a minus 6 over a plus 3 times the quantity of a minus 1. Now we're going to do times the reciprocal of the second fraction. And now we're going to look to just cancel things out here. So since it's multiplication, remember this is like one big fraction. We're just multiplying everything. So I have this a minus 1 and this a minus 1 would end up canceling out. They divide by each other to give you 1. My a to the second power will cancel out with 2 a's on the bottom, leaving us with a single a. So our next step here we're looking at, this is really the same thing as a minus 6 times the quantity of a minus 1 over an a times the quantity of a plus 3. Since we have no more factors that appear in the numerator and the denominator, this would be it. That would be completely simplified. Well, in terms of reducing. Some teachers may actually make you multiply this out to get a squared minus 7a plus 6 over a squared plus 3a. Technically, this is the most factored form, or I'm sorry, the most simplified form, but I am okay with this right here. There's no need to take it any further. All right, last one here. So we have a fraction and a fraction, so we're going to take it here and just rewrite it first. We've got 1 minus x squared over 6x plus 8, and we're dividing it by the x squared plus x minus 2 over 9x squared plus 24x plus 16. All right, with this one, I'm going to go ahead and factor and flip it, change it into multiplication all at the same time. So the first one we've got is 1 minus x times a 1 plus x. That's a difference of squares. In our denominator, we're going to have a common factor here of 2. So when we factor out that 2, we should have left over 3x plus 4. Now I'm going to take it here and I'm going to turn it into multiplication. And then I'm going to take the reciprocal of our second fraction here as I'm factoring it. So this 9x squared plus 24x plus 16 is a perfect square trinomial. We should get 3x plus 4 times 3x plus 4. And on the bottom, that would have been coming from this part here, we should have an x plus 2 and an x minus 1. Now we'll go ahead and look to cancel out anything that we can. Okay, in this case here, we see there's a 3x plus 4 and another 3x plus 4 on the top. And let's see, is there anything else there? That looks like it might be it. Except for when we see x minus 1 and we have 1 minus x, remember this is when we have those opposites. So 1 minus x over x minus 1, right, should end up equaling negative 1. So if you want to end up just canceling it out when you see the opposites, you can do that. Just make sure then this is 1, we'll make this one negative 1. You want to make them both negative because then that won't make any sense there, okay? Because a negative divided by a negative would be a positive. So that would change this from a negative 1 to a positive 1. So let's rewrite it here now as we have a negative quantity of 1 plus x times a quantity of 3x plus 4, and that is over 2 times the quantity of x plus 2. And that should be our final answer. You could also write it with the negative in front of the fraction, like this. Both are acceptable. You could also have that negative in the denominator. All right, so if you have questions, make sure you mark them down, bring them to class. Hopefully this helped you out there. Thanks for watching.